All right, welcome everyone. I want to start out today by thanking you all in advance for spending this hour with us, because I realize that we're standing between many of you and your lunch. So we greatly appreciate your attendance. With that said, let's get a few quick introductions out of the way. I am Timothy Patterson. I typically go by Tim. I'm a senior technical account manager here at AWS. I've been an Amazonian for about 1.5 years now. Prior to joining AWS, I spent approximately 3.5 years on the customer side of the coin, using AWS daily as part of my role as a principal cloud architect. That experience has helped inspire this session. During my tenure at my previous place of employment, a cloud-first and all-in to AWS strategy was adopted. I've lived through many of the challenges that large companies will face along the journey to the cloud. Now, I'm presenting today with my TAM partner. Mind introducing yourself quick?
I am Ryan Wassa, also a technical account manager with AWS. I like to specialize in serverless technologies such as Lambda and API Gateway. I'm a former developer who likes to keep things very agile. I've worked on many large-scale projects in both the public and private sectors, and this background has helped me balance the fine line of technology costs with business needs.
All right, thank you, Ryan. Now that you know who we are, let's talk about what we're doing here today. So the first thing we will do is introduce you to some key thoughts regarding cloud adoption journeys. Then we will walk you through what we think is a pretty cool scenario that illustrates many of the business drivers and decision points that need to be made along the way. We will showcase you some steps that you can take to incrementally move into AWS technologies while also increasing application resiliency, efficiency, and reducing operational overhead. Our scenario will include walkthroughs on how to assemble and utilize various AWS building blocks that are available to you today, all while keeping our eyes on the ultimate prize in architecture, a pure serverless design. If we do our jobs correctly, our mission will be fulfilled. We want to arm you with the knowledge necessary to either further your own cloud adoption journey, or better yet, encourage you to take those first steps towards a transition into serverless architecture. Are you ready?
I am.
Let's go. So first, let's take a look at what we were talking about when we refer to cloud adoption as a journey. Every cloud adoption journey is unique. There is no one-size-fits-all way that customers are moving into the cloud. What we are seeing, though, are some common migration patterns that have emerged over the past decade of AWS's existence. The first migration pattern we see are development test workloads. This holds true for any kind of major technology shift. People like to dip their toes into the water before they jump into the pool. Next, we see brand new applications moving into the cloud. And why not? There are no legacy dependencies, no previous sunk costs, and you get to take full advantage of all the benefits that the AWS platform has to offer right off the get-go. Following brand new applications, we see websites, analytics, and mobile applications. Websites benefit from the global scale of the AWS platform, and analytics, man, it's never been easier to collect vast amounts of data, store it, and analyze it than it is on the cloud. Following that, we have business-critical applications. We see these start to move to the cloud, and we're talking applications that are so critical to your business, you could not survive day-to-day without them. Things like your SAP systems, your inventory management systems, fleet management, things of that nature. Once confidence builds by moving some business-critical applications into the cloud, we then see entire data center migrations, followed closely by all-in to AWS migrations. This is becoming the new normal and is actually an accelerating trend. Now, with all of that said, I want to make something very clear. These are not cookie-cutter steps to follow. Your company's blueprints will look very different than that of your neighbor, and that's okay. So by now you may be thinking, so this is all fine and dandy, but how is this relevant to migrating my applications to a serverless model? Well, the technological journey is also unique. It is important to understand how companies navigate their way into using the cloud, because there's some parallels that can be drawn. Cloud adoption processes pay dividends when looking at which underlying technologies and architectures to use for your applications. Likewise, there is no one-size-fits-all way into getting into a true serverless solution. Today, we're going to walk you through the most common phases of application migration using 2 different applications as our guide. Now, these are just sample applications, but they will transition through the following architectures: completely self-hosted on premises, a hybrid deployment, all in on AWS, and finally, we will arrive at a serverless architecture. In order to move from one phase to the next, there are many obstacles that need to be overcome. And we'll highlight those as we step through these transitions. As with any kind of journey, it helps to know a little bit about your destination. So what is this serverless thing? I'm going to get this out of the way right off the bat. Your application still runs on servers behind the scenes, but all the management is done by AWS. You are not required to provision, scale, or manage any servers. Serverless applications provide 4 main benefits. The first, there's no software or runtime to maintain or administer, no server management. We have flexible scaling. Your application can be scaled automatically by adjusting units of consumption rather than units of individual servers. High availability. The services that your applications are built upon are highly available out of the box. You don't have to worry about architecting them to maintain this high availability. And finally, you don't have to pay for idle capacity. With a serverless technology stack, you only pay when your code is actually executing. Building serverless applications means that your technical staff can focus more on their core product instead of having to worry about and managing operating servers or runtimes, either in the cloud or on premises. This reduced overhead lets employees reclaim time and energy that can be spent on developing great products that scale and are reliable. And I will repeat, again, you are not responsible for provisioning, scaling, and managing any servers. Now, I came across this tweet about a month or so ago. You may recognize the name, Mark Nunikoven. Was kind enough to let us use this. But basically, it goes along these lines. If your idea of serverless involves containers or virtual machines, so on and so forth, I encourage you to think again. The true power of serverless is being set free from the management constraints of the past. So let's kick off our journey today and take a look at our scenario, the business. Now, I do want to point out this is a completely fictitious example that we'll be using today, but it illustrates a very plausible situation. So without further ado, Pegasus Pickups. They are a world-class premier transportation service that gets people to their destination in elegant style. They're the first successful worldwide exotic ride service. You simply request a ride, and a Pegasus will swoop down from the sky and pick you up. Pegasus Pickups has enjoyed a monopoly in their market for many years. And they are currently hosting their set of applications in their on-premises data centers. And they've been operating this way since the beginning. So what's wrong with this? On the surface, not a thing. However, I now want to introduce you to another company, Wild Rides. You may have seen this company before if you've taken part in one of our serverless workshops or game day sessions. Wild Rides completely disrupted the exotic ride market. Their unmatched agility and pace of innovation has allowed them to overtake Pegasus Pickups within just 6 months of their inception. Wild Rides offers end users rides on unicorns and offers more features and a better user experience. Perhaps most interestingly, their sudden success has been directly attributed to the fact that they were born on the cloud. They use a pure serverless architecture, and they're able to focus more on innovation and less on infrastructure. Does this sound familiar to you at all?
Yes, it does.
Yeah, there are many long-standing businesses that have been completely disrupted by fast-moving startups in recent times. So now that we know who the players in the market are, let's take a look at the actual applications for Pegasus Pickups. At a high level, things seem pretty simple. We have a web and mobile application that users can use to request a ride from anywhere at any time. We also have a batch processing application that churns through various incoming data sources for things like business analytics, fleet management, and to add more user features. Pegasus Pickups is also a firm believer in open source technologies. They have standardized themselves on a LAMP stack, which is Linux, Apache, MySQL, and PHP, for their software layer. Their batch processing application relies heavily on NFS. They're using it for distributed file processing, as well as using it as a queuing system with folders inside of their file system. Today, the application components are tightly coupled and are monolithically structured. So now that we have the necessary background information, let's suppose that I just got hired as a lead architect for Pegasus Pickups. I'm always looking for a new challenge and figured, hey, why not? This is what I walked into. The primary application data center is located here in Las Vegas. There's not anything too shocking about this architecture. It's a pretty well-adopted design. On the bottom of the stack, we have NFS storage for our batch processing application. Working our way up, we have some web clusters, some batch management clusters for compute. We have a redundant set of load balancers out front, as well as a redundant set of core routers for connectivity out to the internet. Oh, by the way, at Pegasus Pickups, we are fully responsible for not only the hardware, but also the data center environment, the operating system, software. This means that we have to pay for and manage cooling, electricity, and physical security. On the logical side, we have to maintain, patch, license, administrate all parts of the environment. As if these tasks were not enough, we also have a second data center facility for disaster recovery purposes. This one's located in Ann Arbor, Michigan. Since we have a second location, we have to establish network connectivity. So we have some dedicated circuits for a VPN connection. Due to our heavy reliance on NFS, we also had to provision a storage replication circuit. So let me tell you about some of the problems that we are facing with this environment. Number one, things are moving too slowly. It takes 10 to 18 weeks to provision hardware. This means that if a team within Pegasus Pickups has a new idea that they want to try out, it could possibly take this long to get resources before they can ever write code. Data centers are expensive. Facility costs, so on and so forth. We get the idea. Pegasus Pickups is responsible for both physical and logical security. This is tedious work. Staff is spending too much time just keeping the lights on. All of these things put together equal too much undifferentiated heavy lifting. Now, this is a phrase that was coined by AWS's VP and CTO, Werner Vogels. It refers to the fact that all this time and effort we are putting into just keeping the lights on is detracting from the time we could be spending on innovation. What else is going on with Pegasus Pickups? Well, obviously, with the introduction of wild rides, we are seeing increased competitive pressure, which leads to frustrated C-level executives. We're not able to keep up with these new guys. There's no time for innovation. We're keeping the lights on. Agility is non-existent. Perhaps most terrifying is our revenue has drastically decreased. So what does all this mean? The heat is on. We've heard the question asked many times, how can we possibly recover from this? Now at this point, I'm strange, I'm getting excited because I get to pitch my first idea as a Pegasus Pickups employee. Hybrid to the rescue. So you might be thinking, wait, now hold up, isn't AWS a public cloud provider? Well, yes, but a hybrid environment offers many benefits for companies who currently own, maintain, and deploy their own assets. You can take advantage of existing resources before they reach their shelf life. Businesses will still realize results. You gain the advantages that the AWS platform has to offer. And what I mean here is scale. You don't have to wait for hardware to be procured. AWS has actually been enabling hybrid architectures from the start. Think about it. Services like VPC, VPN, Direct Connect, they've all been built to connect your private data center up to the cloud. And we continue to innovate on hybrid technologies, as you'll see very shortly. So let's focus on the web tier. How would we actually transition into a hybrid environment from what we have today? Well, you can either choose a subset of your applications to migrate, or you can just burst out into the cloud. Let's look at how I helped Pegasus Pickups migrate into a hybrid model. The first step, we're going to pick a region and create a VPC. Next, we need some subnets. So I'll create 2 public subnets, one in each availability zone within the region. This is for redundancy purposes. Now, we're going to need a way to talk back to our on-premises data centers. So now is the time to establish a VPN connection between our on-premises data center and our VPC. Now, you have to look at your application requirements. Maybe a VPN over the internet just isn't fast enough. At that point, you would also have to look at perhaps a direct connect connection into the AWS region. The next step, we're going to swing DNS over to Amazon Route 53, our DNS service. This step gives us flexibility into which location we direct our customer traffic into. By migrating DNS into Route 53, we gain some important functionality that we didn't have on premises before. For example, we now have the ability to perform health checks against our web application endpoints. We also have the ability to deploy weighted record sets, which allow us to direct percentages of our traffic at any given environment. Oh, by the way, Route 53 has a 100% availability SLA.
It's pretty hard to beat.
That is pretty hard to beat. Next up, create an application load balancer. So application load balancers choose some subnets that they will deploy into. In this case, we're deploying them into our public subnet, and we're giving this application load balancer a public IPv4 facing IP address, so it's internet routable. Now, AOBs work with a construct called a target group, and there are two kinds of target groups. One is an IP type, and one is an instance type. For this AOB, we chose IP type, which simply means that the AOB will direct traffic into specified IP addresses that reside behind it. This will make a little more sense in a few moments. Next up, we're going to create a network load balancer. NLBs are very similar to AOBs, but operate at a lower level in the TCP stack. We're going to create this NLB, but we're going to use a target group type of instance. Instance target groups can be associated with EC2 instances, or better yet, an auto-scaling group. So, along those lines, let's create an auto-scaling group. But first, we have to create our launch configuration. The launch configuration is a construct that defines what AMI we're going to use, what instance type, and it also holds our user data for bootstrapping our web application and the web server itself. So we'll create the ASG across the two AZs with a minimum construct of 2. This means that there will always be 2 web servers in service. Next, we're going to register the ASG with the NLB's target group. Remember, it's an instance type target group. Next, this is where things get a little interesting. We're going to look up the NLB's IP addresses and add them as targets in the AOB's target group. What's wonderful about network load balancers is when they're provisioned into a subnet, it provides an ENI, or Elastic Network Interface, behind the scenes. Those ENIs hold IP addresses that are private and static within the VPC subnet CIDR range. So we can simply do a DNS lookup against NLB to obtain those addresses and be assured that they will not change. So we grab those and we'll add them to the AOB's target group. Next, we're going to look up our load balancers on premises and add those to the AOB's target group, since the AOB can talk across VPN connections. And then finally, we'll change Amazon Route 53 DNS to point to our AOB. Now, this architecture accomplishes quite a bit for us. First of all, the obvious. It allows us to instantly scale our web tier capacity as needed on demand. More than that, though, we can now move portions of our existing on-premises application at will to AWS at any time. The use of the AOB instead of a reliance on DNS alone allows us the flexibility we need to migrate specific URLs of our application as opposed to taking an all-or-nothing approach. This dramatically eases our cloud adoption. It also sets us up nicely for a more forward-looking move into an all-in and AWS architecture. We have not painted ourselves into any corners that cannot be easily undone by introducing unnecessary dependencies. This architecture is made possible by recent AWS innovations. AOBs, NLBs, and the capability to refer to IP address-based targets are all somewhat new features that have been released in the past 16 months. When making any kind of an architectural decision, step 1 is to analyze the tool set available to you. It should be a part of your daily or weekly routine to study new feature releases. This helps you avoid reinventing the wheel and in many cases can save you time, effort, and money. It's also important to understand your constraints and how to work around them. For example, today, the network load balancers, they can't be accessed via VPC peering or over an AWS VPN connection, which is why we have the AOB out front. You can, however, get around this. You can use a software-based EC2 VPN to bypass these restrictions. You can use like OpenVPN or something from our AWS Marketplace. Additionally, stay abreast of new features. For example, just on Tuesday, we released Private Link with custom endpoints. This would allow you to provision a network load balancer and shoot an ENI that could be accessible from on-premises. Just things to keep in mind. Now that we have taken the initial plunge into a hybrid architecture, let's take a look at what's next. What more can we do? We have the database tier. MySQL, it can be migrated to run on either EC2 or RDS, our relational database service. You can get the data there by either using MySQL's own native replication mechanisms or the AWS Database Migration Service. Staying true to knowing your constraints, you have to know what the service can and cannot do. So when using native replication, the MySQL instance external to RDS must be running the same or later version of the database engine. To get around that, you could use AWS Database Migration Service. It is very useful and handy for moving across DB engine versions, amongst many other things that it can do. What else can we do here? Well, networking. If you haven't yet already established Direct Connect in the beginning, now's the time to take a look at it. You can establish high-speed connectivity into the region you've deployed into. Today, AWS offers dedicated connections of 1 gigabit per second and 10 gigabits per second. You can get varying speeds by working through a partner through our APN network. Availability. We've only deployed into 2 AZs within a single region. I know that US East 2 has more regions, or more AZs than that. Let's consider that if we need further levels of availability or even replicating into a new region altogether. Since our batch processing application relies heavily on NFS, we'll need a solid solution in AWS before we can even attempt to migrate this application. So what can we do? If you have established a Direct Connect connection, you can migrate away from the on-premises NFS storage in favor of EFS. EFS has a few benefits that are unique. They can be mounted via on-premises systems through Direct Connect. That's pretty cool. It'll help us move our data. EFS shares can be mounted across multiple availability zones within a single region using a single DNS endpoint, which simplifies configuration and enables high availability. With EFS, you only pay for what you use. There's no more sunk storage costs or guesstimating how much storage you might need moving forward. By migrating the storage to EFS, that allows us to move the batch processing application to AWS. We really don't want to have to rely on a Direct Connect link for our servers running in AWS to reach back to on-premises storage systems. This empowers you to take advantage of auto-scaling groups for that batch processing workloads. This is going to help tremendously. It'll give us increased elasticity, which equals reduced costs. It'll give us less infrastructure to manage, which is more agility. We have more time to work on things. Increased agility, more innovation. I'm starting to like this cloud thing. So now that we've seen some real results for our core business, let's take a look at what more we can really do to transform our business. While it's true that a hybrid computing model adds many benefits to an organization like ours that has traditionally been hosted entirely in an on-premises fashion, hybrid is just one step in our transformational journey. We now have some very serious points to ponder. What happens when my hardware is up for a refresh? Do I really want to renew the lease of my data center facilities? What additional benefits could I get from pushing further into the cloud? As these items are discussed, the next step of our journey becomes more and more clear. How about all in on AWS?
Doesn't that seem like a pretty bold move?
Well, looking back 5 years ago, sure. Today though, nah, cloud has become the new normal. And all-in migrations are actually a very accelerating trend. And it makes sense. Think about it. The hybrid stop in our journey has already laid the framework for the remaining migration activities. By moving to an all-in and AWS model, you are simply amplifying the benefits that you realize in the hybrid state. So let's crank up the volume. I want even more agility, even more elasticity, and even better cost savings. These items combined will give me an increased operational velocity. Things are just moving forward faster and faster as time moves on. So let's take a peek at what this might actually look like and put the pedal to the metal. With this architecture, we have finished implementing the next steps we discussed with the hybrid deployment. Customer traffic now resides entirely within AWS.
That looks a little complicated.
Yeah, you might be thinking that looks a little complicated. While it might seem daunting at first, Let's just walk through each of the moving parts and discuss how we assembled the AWS building blocks to end up here. We'll start by zeroing in on the web tier again. What's changed? Well, the web servers now sit directly behind the application load balancer. The LB is no longer necessary. It was a migration interim step. Now, to get out of it, we simply attach the web server's target group to a brand new application load balancer and switch DNS. That's simple. We can begin to move static web assets, things like images and CSS files, into an S3 bucket to be served. It takes a little bit of extra load off of our web servers. We can also introduce CloudFront to cache this stuff out front. Also, we've removed the DNS entries from Route 53 to our on-premises systems. This completely severs ties with those systems. We are now all in for the web. At this point, the VPN is actually no longer necessary. I have a little star there, though. My point here is that it's no longer functionally necessary for the web tier to operate. It doesn't have to reach back to on-premises systems. You may wish to keep it around for management or data transfer purposes moving forward. Let's look at the batch processing layer. What's changed here? Well, we've fully moved the batch processing nodes into AWS. We've introduced SQS, our simple queuing service. This is intended to replace the NFS polling mechanism. It allows us to auto-scale based on the actual number of jobs in the queue versus something like a metric, such as system CPU. This enables us to move even faster with our parallel processing workloads. It operates completely in a private subnet environment within our VPC. And it utilizes NAT Gateway to access the SQS service, as well as the internet for application and operating system updates. Finally, let's take a look at the database tier. What's changed here? Well, we finished migrating entirely into RDS, which is awesome. It's fully managed. It gives us automated patching and backups, and it can scale vertically if necessary. Now, I'm not just talking instance sizes anymore. As of last week, you can also scale up your EBS volumes behind those instances that house your database. That's pretty cool. Automated read replicas are available for use. This gives you increased redundancy, and it can be used to speed up read-only operations, such as batch and web operations. The read replica can also take over as a database master in case of a primary node failure. This gives us an extra layer of redundancy. When we put it all together, we end up with a highly available, fault-tolerant, and scalable architecture that allows us to completely shut down our own data centers. There are no more sunk costs and no more worrying about the physical infrastructure to support our computing environment. This is all accomplished with very little changes to the application itself. Instead, we relied on pure architecture to guide us to this point in our journey. Our hybrid step set us up beautifully for this all-in transition. I'm going to remind everybody, though, that every journey is unique. While useful, the hybrid step is not a hard requirement. There are many other organizations that have achieved an all-in architecture while skipping hybrid altogether. My advice is to simply analyze your requirements and do what works best for you and your stakeholders. Now let's change gears a little bit. Let's take a peek at what kind of tooling we can use while working with AWS to enable continuous integration and continuous deployment. Most organizations have a code repository that houses their application. Here at Pegasus Pickups, we utilize a simple Git repository for not only our application code, but also our infrastructure. It has different branches that correspond with different environments. For example, staging, production, development. We utilize Jenkins to coordinate the deployment of our infrastructure. Jenkins is responsible for provisioning and updating the infrastructure into the AWS accounts that correspond with each environment. I strongly encourage you to lean on CloudFormation to do the heavy lifting. It removes you from having to carefully coordinate AWS CLI or API commands in order to stand up the entire platform. CloudFormation is very intelligent, and it will do both your initial stand-up as well as atomic updates moving forward. Now that we've seen the journey to an all-in architecture unfold, let's talk about some of the potential blockers that we may have run into along the way. Cost. In my experience, cost is the first thing that organizations bring up as a potential blocker. But is it really a blocker? Remember that in AWS, you only pay for what you use. With that said, in order to realize the most significant cost savings opportunities, it is true that some architectures may require an initial upfront investment in the form of reserved instances for baseline capacity and possibly even network connectivity. I'm talking like direct connect here. This depends on your application requirements, of course, and your budgetary capabilities. I encourage you to challenge any potential misconceptions around cost and weigh the long-term benefits against the short-term investments. Because remember, you will be saving money in an all-in architecture through elasticity, only using the resources that your application actually needs at the time. Next up, training. It's no secret that some staff members or employees will feel threatened by a move into the cloud. The goal of a cloud migration is to empower these employees to shine. Some retraining on new technologies will be necessary. My advice to you is to create a supportive and friendly environment for the skill set transformation to take place. Encourage your peers via things like lunch and learns. You can buy me lunch. Formalize training and build your own internal center of excellence for these teams to learn from. Business deadlines. This one's self-explanatory. You may have competing priorities. You might not be able to focus on a migration. But in the case of Pegasus Pickups, it was absolutely critical. We were being put out of business by our competitors. Finally, compliance and regulatory requirements. Now, I will say that AWS has a full portfolio of services that can be used for the most common regulatory compliance requirements, such as PCI, HIPAA, even data sovereignty requirements. So I encourage you to take a deeper look at that. We have a ton of information on our website that goes more into detail for those sorts of things. So what more can we do to enhance our all-in deployment? The most important advice I can give you is to never stop looking for ways to improve your architecture. Look for ways to improve performance and reduce costs. If you find a pain point in the architecture, be sure to look at all of the options available in your toolbox. One example that comes quickly to mind is what happens if your database becomes suddenly overloaded with repetitive queries. A quick peek at existing building blocks may yield something like Elasticache as an answer. AWS has many services that can quickly solve common problems like these. So, at this point in time, I just want to say congratulations. We've completed our journey into an all-in AWS architecture. It's time to sit back and reap the rewards of our labor. I mean, hey, we have more operational velocity thanks to the completion of this project. No more undifferentiated heavy lifting. No more hardware for us. There we go. Now we can sleep well at night knowing that we are fully optimized and watch as our development teams can focus on innovation that lets us catch up to those pesky wild rides folks. But hold up. Why stop here? Just because we're all in doesn't mean we're at the end of our journey. Well, it can't be that easy. Let's keep that velocity. So now that I have helped to transition into an all-in architecture and things are running smoothly, I'm going to go on an extended vacation without having to worry about pager duty. I mean, hey, the environment is self-healing and highly available due to our redundancy, right? So to fill the void during my absence, Pegasus Pickups has hired this hotshot developer, Mr. Wassa. He's tasked with one thing, keeping our velocity by moving from where we are now into the serverless architecture of the promised land. Mr. Wassa, it's all you.
All right, Tim, thank you for that history lesson. While you're living up at the beach, we'll finish the job. Once I was hired by Pegasus Pickups, I had one goal in mind, to get rid of servers and focus more on development. Why should we maintain any kind of server stacks when somebody else can do that for us? Magnum PI. Why should we pay for any kind of server stacks when we only have to pay when our code is actually being executed? So after looking at it, I came up with this serverless architecture. I felt that this architecture gave us the most cost-effective way to transform and stay competitive. We'll cover some of the blockers we encountered and show a few phases of the transition. We'll also show the point at which we introduced a few of these services along our journey. And a reminder for everybody that there is no one-size-fits-all migration, and that's because of the flexibility that serverless architectures afford us. Some of these steps can be done in different orders depending on your current cloud adoption today. So first, let's cover the blockers. Fear of the unknown. Enterprises try to stick with what's comfortable or working for them. I mean, Tim's mind's already in the Bahamas by now because he's not worried about being paged. So why should we transform into serverless? We also often dismiss new technologies because we don't necessarily understand them, when in reality, the serverless architectures are the same technologies that you're using today, they're just used a little bit differently. Legacy code. This is difficult in any transformation. We've all had that moment when we've pulled from our Git repository, looked at the code and gone, what does this do? After 5 or 10 more minutes, we're looking at it going, no, seriously, what does this do? With our approach, you can run legacy code side by side with new code, giving you time to remember what that code actually does. It's also a great excuse to shed some of that technical debt in case you find out that it doesn't actually do anything. Other priorities. We all have those tasks that just slow us down from things we want to do or need to do. Tasks like fighting daily fires, running reports, can make it difficult to focus on transformation projects. This phased approach means that you can tackle these in smaller tasks as time allows. And lastly, handcuffed. Traditionally, time and costs are a major concern for management with projects like this. With these steps, we'll show how it can not only be cost-effective for development, but save on current costs as you're transitioning. So let's go back to that all-in architecture. We're going to focus on the web tier first. We want to start by double-checking to ensure our static content is 100% removed from these web servers. We don't want to be generating dynamic HTML and rendering that back to our users. Dynamic content should be driven by static HTML and JavaScript, and will ensure that CloudFront is stood up for global delivery of our application. This first step required some work by our teams, but we were able to tame a Pegasus, so it was pretty easy. Now we want to stand up the API gateway, and for each of our APIs that are still in our application load balancer, we want to create a corresponding endpoint in the API gateway. We then need to update and we'll create that as a proxied endpoint. We then want to update our DNS record, and instead of pointing to the application load balancer set up by Tim, we'll point it to the new API gateway. All this step does is create another layer in our web request, but it sets us up for some much needed flexibility as we move forward. We can now swing various parts of our application over to Lambda functions as time allows, which is great if we need to fight those fires or run a report. After we've got that layer in place and we got that flexibility, we want to focus on our authentication. Here, we're giving API Gateway the ability to authenticate every web request. And for this, we've chosen Amazon Cognito, which gives us a lot of flexibility, and then we combine it with custom authorizers. As you can imagine, everybody wants to be picked up by a Pegasus, so we have to support a lot of different authentication mechanisms, and this allows us to do that. Our custom authorizers will authenticate users and return that information back up to the API Gateway. The API Gateway will then send that information down to our endpoints in the form of the context object, and we can perform finer-grained authorization later on. So once we've added that security in our API layer, and we know that the API Gateway is serving our content that way, it's time to focus on the code itself. So in my experience with large projects, there's usually a distinction between web developers or backend developers. With serverless, this is reduced because we're all developing in the same area. This distinction between web logic and batch logic really is in how they are initiated. For us, web logic can only come through the API Gateway, while batch processing can be triggered by an end user via API call, an S3 event triggered from an object upload to S3, or even a scheduled task to kick off a Lambda function.
How do step functions fit into all this?
It's a good question. So step functions is a custom state machine that can perform orchestrated processing for us. We're not there yet, but we'll eventually use this. When a user uploads a photo to an S3 bucket, we can then resize the photo, run various lens filters all in parallel, and then finish it off. So at this time, we also started moving from our RDS instances over to DynamoDB, a NoSQL engine. This isn't a step that we necessarily needed to take, as most of the code that you can run in Lambda can connect to an RDS instance, but we felt that DynamoDB fit our workload much better. They also released some features such as DynamoDB Accelerator and auto-scaling, which help support bursty workloads. We've also incorporated the simple queuing service, SQS, as a dead letter queue to retry any failed Lambda functions. We've incorporated SNS, or the simple notification service, for text messaging and mobile push notifications to let our users know that their Pegasus is right around the corner. And then once all that's in place, we now want to start moving our actual web logic. Each API endpoint that is being proxied to the application load balancer will become a new Lambda function itself. During the migration, we want to ensure our functions are stateless, meaning we aren't pulling any of the user state at the beginning of the request, performing our work, and then saving it at the end. This allows our functions to remain small and reduce the latency in our web layer. Remember, the user information will come from Lambda in the form of context variables, so we'll know who the users are in each of those web requests. As each function is completed, we can simply deploy the Lambda function, then update the Swagger definition for our API gateway, and point to our endpoint in the new Lambda function instead of the application load balancer. As each endpoint is swung over, it reduces the load on our existing web servers, meaning that we can cut back the amount that we are keeping in service. And right here is where we start seeing some of that cost savings in our current infrastructure. Once all of the endpoints are pointed at Lambda and all of the batch processing logic is in Lambda, our code migration is complete and we no longer need the EC2 instances. This meant I took great pleasure in deleting Tim's EC2 stacks. So some additional thoughts on serverless architectures. Depending on the language that you're using today, some of these transitions might be pretty easy. If your APIs are already written in languages such as Java, .NET, Node, or Python, no. It might be as simple as copying the code, adding or removing a few libraries, and the function will just run. Just like everything else in AWS, you only pay for what you use. Typically, costs for a project like this are a big factor, but with a small project or a medium-sized project, you can take advantage of the AWS free tier, and you're able to perform your development for tens of dollars a month versus hundreds or even thousands if you're paying for your own equipment. Management can quickly remove those shackles. Lastly, deprovision without risk. No commitments means that you can tear down your serverless stack anytime you need to. You're not pre-provisioning anything or feeling obligated to continue a project because you've committed to resources. During this praise, we continued to use the same CI/CD tools that we did in our all-in architecture. To deploy serverless, we need to ensure that we had updated AWS CLI, as well as the AWS Serverless Application Model, or SAM tools. SAM can be thought of as CloudFormation with a little bit of magic wrapped around it. Because we use CloudFormation in our existing architectures, it was pretty easy to learn SAM and little nuances of it. And we didn't need to do this, but we decided to move our tool serverless as well. The AWS CodeStar suite is a series of AWS services that gives you a serverless CI/CD pipeline. So let's see how these tools relate. On the left, we have a simplified Jenkins deployment. Commits to our repo trigger a Jenkins build and deploy into our AWS account. On the right, we have a simplified CodeStar deployment. Creating a CodeStar project will create the necessary code services for you to use, such as code commit, code pipeline, and code build. Code commit is essentially our Git repository. Code pipeline can be thought of as your Jenkins project, which lists the build order and contains other information about your project. And code build is where you build, test, deploy commands can be run.
Oh, that's where the real magic happens, huh?
It is. On the left side, the Jenkins, it really doesn't understand your AWS account. While it may run inside your AWS account, everything that you're doing is actually being provisioned. On the other hand, as we continue to innovate and integrate, CodeStar services are able to manage your AWS resources natively, which means that it is truly running within your account. So now we have not only moved our application to a serverless model, but our tools are serverless as well.
So at the end of the day, the scenario that we detailed is just one of many paths that an organization may choose to take. And as with any kind of migration effort, just ensure that you're doing what matters most to you and your business. Look at the requirements, look at the constraints, look at the workarounds, look at the cost. In the case of Pegasus pickups, we fully eliminated the need for actual hardware and drastically reduced operational costs.
Serverless is going to transform how we do business. This will allow us to focus on development and innovation instead of our infrastructures. And these tools are already in our toolbox today. It can't just be a buzzword or a dream anymore.
Awesome. At this time, we do have a few minutes for questions and answers. If anybody would like to ask us anything about our slides, anything you may have seen that was interesting. I know that there are 4 microphones in the room. I just kindly ask that you say your name, what your question is, and we'll do our best to answer for you.
I can't see.
Everybody's hungry. Yes, sir.
I will ask. John Peacock.
Yes.
Wasn't clear to me what the NLB was doing for you in that transition stage.
Yeah, so the NLB gave us private static IP addresses within our VPC. That allowed us to use the IP address mode of the application load balancer. Because we had a split environment, we needed to be able to point to our on-premises load balancers via IP address. So that's our solution. We had to have the back-end static addresses because we were forced into using an IP address target group on our AOB. Unfortunately, you can't have 2 target groups on an AOB listening on the same port of 2 different types. So it was a constraint that we had to find a way to work around. I believe there's one more question up front. CodeStar. CodeStar is killing you. Oh no. Okay, what? Cold start with Lambda. Okay, I gotcha. With Java. Yes. I know that that's a fairly common request. Ryan, do you have anything to add to that one?
No, all I know is that it is something that we are working on. I'm sorry, what was that? I can't hear.
Can you use code pipeline in the hybrid solution? Yes, absolutely. Yes. There is not a one-to-one correlation between moving your tool set serverless and having the architecture there already. I mean, you can choose to move either one at any point in time. And there are agents that can run on premises as well if you so choose to use those same services with an on-prem solution. Yep. Yes, sir. So the question is there any reason for not having static IP support on the AOB and maybe even the classic EOB? I think the answer lies in how those are built behind the scenes. I really don't have a concrete answer there for you, but it is a feature we hear a lot. And we'll take that back to the service team as a +1. Yes, you are correct. Right now, in order to jump to that hybrid state, we do need that extra layer. I will point out, though, that this is something that wasn't even possible about a year ago. So this is an entirely new method of moving into a hybrid architecture. Before, you were essentially limited to DNS or running your own kind of software load balancer on top of EC2. And all I can say is, I mean, Amazon's pace of innovation is not slowing down. Focus on that space and we'll see what comes. Yep.
Hi. Do you have any insight into trade-offs between like the lift and shift hybrid solution that I think you showed here and more of like a chunking type solution where you take functionality out of your on-prem application and port them into like Lambdas and like a serverless solution? Without shifting your existing application into the cloud?
Yeah, absolutely. I think we can both tackle that question for you. There is nothing stopping you from chunking your application apart and moving things in that direction. It would require a little bit of a hybrid setup that's unique. We would have an API gateway out front that would handle some of your Lambda calls that could still point to an ALB that would refer to other resources. With the ALB, what's beautiful about it and a benefit is you can use the path-based listeners to migrate specific URLs of your application at that point. So you could migrate specific URLs over to Lambda calls.
Quick question also relating to Lambda. I'm kind of getting my head around it, but is there a facility or a way to kind of share code or services between Lambdas?
Not between them directly, but what you can do is you can create like your own shared library and then package it up with each of your Lambda functions through your CI/CD pipelines.
But in sort of a traditional model, where if you had some kind of singleton service, that would pretty much, each Lambda would start up that service, its own copy of it.
Yes. Yep. They are meant to be their own little functions and work in their own little environments.
Yeah, it really empowers a microservices architecture.
Hey, question about, do you recommend to have like every request as Lambda, not like every request per se as a Lambda function for the whole web application, like everything Lambda?
Yeah, we're seeing many applications today that are entirely serverless. The HTML and static assets will be served off of like S3 and CloudFront. And then the JavaScript SDK will actually work with our STS service to obtain secure tokens. And every dynamic request goes through the JavaScript API into a Lambda function.
Okay, but wouldn't that get like crazy expensive if you do like 100,000 to million requests per minute or second?
I can't remember the current price of Lambda, but it's a dot with a lot of zeros and then a 1. I wouldn't say that would be any more expensive than running static EC2 instances all the time to provide that same sort of service. But again, I would have to encourage you to do your own cost-benefit analysis based on the number of requests.
And if you're using the API gateway in front of Lambda, then you can actually cache some of the things that are happening more frequently, and then the API gateway will return that cache instead of firing those Lambda functions repeatedly. So that can save a little bit as well.
All right, thank you.
Hi guys, this was great. Mike DiStefano. You didn't talk too much about step functions, but if you're hosting mostly a batch application which is orchestrated today, let's say via scheduler, are step functions meant to be the orchestration tool that replaces a scheduling-based application?
Yeah, it can be. I mean, you can go straight to Lambda depending on what kind of processing you're doing, but I look at step functions as a really good tool for that batch processing workload. I would not use it for web requests.
Yeah, I'm talking strictly batch applications where you perhaps have a workload of hundreds of jobs. Scripting all that inside of a step function seems to be a little bit hardwiring those dependencies within a script. Is there anything that loosely couples jobs together?
I would actually argue that step functions would accomplish that because step functions manage state for every execution. So let's say that you're doing document processing, for example. You have one document that takes 5 minutes, the other takes 20. The next step would not fire until the first execution was completed. Does that make sense?
Yeah, I mean, I see that's how step functions work, but that tightly couples those components together inside of a script, a deployed script,
yes,
as opposed to a scheduling application that would be mostly database entries. So is there anything alternative to step functions that more loosely couples components and dependencies together?
Maybe not in the serverless realm of things, but we do have a product called AWS Batch that's specifically built for that sort of thing, but that does utilize EC2 instances behind the scenes.
Okay, thanks.
And if you want, after this, we can get together and we can talk about it a little bit more.
I appreciate that, thanks.
Sure.
All right.
Now it's hard to see.
Well, thank you, everybody, for your time today. I want to, thanks.
Thank you.
I'd like to kindly remind you to take take some time and rate our session today. It gives us valuable feedback as to what you would like to see us do better in the future. So everybody take care. We wish you a great reInvent.
Thank you.